right, timers are set. Proportions in triangles. 7.5, we're going to get that. We got a few new theorems we need to get in here. You've probably already been exposed to the one in con for the angle bisector, but there's another one that's pretty cool that we need to learn so that we can use it. All right, take a second and do the front page. All right, you have now gotten the front page done. The warm-up section, the lead-in skills, if you will. And now let us begin by checking those answers. All right, so which ones should you have circled with a proportion that can form a proportion with 10 to 15? So basically it has a matching ratio. This guy. Okay? Questions, please ask. Which ratios form a proportion? These two. If you set 3/4 equal to 75 hundredths, they're going to have the same value, and then the cross products will be the same. Which proportion does not have the same solution as the others? The one you should have crossed out should have been this guy. Okay? Cross products are different. 1720. N17, 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 2012, 2012, 2012. Okay, vocab builder. Bisector. Divides a whole into two equal parts. Bisector is a point, segment, or ray, or line that divides an angle or a segment into two congruent angles or segments. We've learned about a perpendicular bisector. We've learned about making congruent angles. Now we're going to talk about an angle bisector. Okay, so there you go. All right, ray BD is the bisector of angle ABC. Angle ABC is bisected by ray BD. Ray BD bisects angle ABC. All right. Let's flip to get into the meat and potatoes of the lesson. And this right here, we did not have a con exercise on, but we do have the IXL bullet that I posted today is get some good extra practice if we have IXL memberships at this time. Side splitter theorem. All right, if a line is parallel to one side of a triangle, so right there, so this is parallel to here, and intersects the two other sides, then it divides them proportionally. All right, there you go. That's what that's saying. It's saying it divides this side proportionally to this side. So if line RS is parallel to XY, RS parallel to XY, then XR, the relationship of XR to RQ is going to be the same as XR to RQ is going to be the same as relative to XR is going to be the YS, and then relative to the RQ is going to be the SQ right there. So if RQ equals 4, if XR equals 4, RQ equals 4, and YS equals 5, okay, then SQ is also going to equal 5. But now they're going to change it up. See, they were showing they were equal. Talking about this one was this one and this one were equal, so therefore that one and that one are going to be equal. Now XR, if XR was 3 right here, so I'm going to fill this in this time. Okay, if this was 3, right? And RQ was 6, and this is what I would recommend for you to do on any problems, 3 to 6. And then this was 4, okay? You could set that up in a ratio as 6 over 3 equals unknown over 4. 3x equals 24. And then x equals 8. Or you could have spotted that this is double the size of that, so that's going to be double the size of that. So the corollary, okay, so kind of like, you know, you get just basically a different look. It's the exact same idea. Here's your parallel lines, but now you got more. These don't necessarily get ended with a triangle, or do they? Because they're going to get intersected right there. So you got A, B, and C are parallel. Okay, so AB to BC is to WX to XY. Okay, So you got to keep the cross products the same. So BC's got to get by x WX and AB the XY. Again, you can write a proportion 8 different ways. And here's where we're writing it at least 3 different ways. Well, we got this guy, and then so we're going to write it a total of 4 different ways here. BC, so BC to AB, so they stayed here. BC to AB is going to be XY to WX right there. And then I'm gonna look at this side first, since this has got my unknown. So they got YX, YX, YX to XW is going to be CB to BA. AC, the whole to this part, AC to AB, the whole to this part is going to be the whole to that part. Alright? And then you can use it by filling it in with unknowns. Okay, so using the side splitter theorem. Okay. So they do all the using. We're just going to kind of fill in the proof. Okay, what is the value of A? So you've got some, you could do this a couple different ways. Okay. All right. Use the reasons in the box to justify each step. So they set up A to A over 4, so that's going to be 12 to 18, right? So that was just this. That's where using the side splitter theorem. Okay. And then obviously what we did here was we did the cross products property. Okay, then what we did here, we subtracted 12 from both sides. Okay, so or 12a, subtract 12a from both sides. Okay, and then 6a equals 48. What did we do here? We simplified. Okay, then I'm looking what change. Okay, we divided each side by 6. Okay, and then we simplified again. And what we just did here was we justified, which is kind of what a proof is. All right. So we're going to hop on over to finding a length. Finding a length right here. Okay. So we are camping. What's up, bud? We are camping, and we got 3 campsites are shown in this diagram. Okay, this is just an application problem of the same thing. You should see here, this is the corollary to that side splitter theorem. Oh, that's even what they put in the notes right there. Okay, camping's got 3 sites. What is the length of site C along the road? Okay, and let Y be the length of site C. So what I'm going to do here is I'm going to put just a Y right there, right? Use the justifications at the right. Okay, so Y is to 7.2 is going to be to 6.4 over 8 right there. Okay? And then what did we do? We did the cross products property, just like before. So we're going to do 8 times Y. Okay? And then what we're going to do, we're going to divide both sides by 8. And then we get Y equals 5.76. So this is going to have a length of 5.76 yards. Okay? All right, so that's the first half of the notes, okay, on the side splitter theorem and the corollary to the side splitter theorem. So at this time, we'll end this recording, and we'll start the next one for the triangle angle bisector theorem.